Welcome to Notes 2.3, Product and Quotient Rule for Differentiation. All right, so let's look at some examples of why we would use the product rule and how we would use it. All right, let's say we have two functions, both of which have a variable in them, and we want to multiply those two functions together. There seems to be a delay in the pen. I hope that's not going to be a problem. All right, if we have two factors, each of which have a variable in them, and think of two binomials that get multiplied together, where in each of the binomials you have a variable. Okay, if I want to find the derivative, okay, of a product of two factors that have variables in them, if I brought in the derivative operator, I'll kind of wrap this up in brackets. Remember, we're not multiplying by the derivative operator, we're applying the derivative operator. All right, so what is the derivative of a product like this? I'm going to work across instead of down on this one. Well, unfortunately, it is not going to be f prime times g prime. That would be too easy. That would be nice, but it'd be too easy. All right, the product rule for differentiation says that we're going to take the first factor, f of x, and we're going to leave it alone. But we're going to multiply it by the derivative of the second variable factor, and the notation for that would be g prime of x. Not real sure what happened to my f of x here. Plus, and then we're going to move on to the second variable factor, leave it alone, and then multiply the second variable factor times the derivative of the first. So what that looks like is g of x times f prime of x. So that's the product rule for differentiation. So let's look at some examples of how that would look. All right, when you first glance at this problem right here, you see we have a product of two variable factors. You can consider this first binomial a factor, and this second binomial is another factor. So if I wanted to, I could think about the first factor, or the first binomial right here, as my f function, and I could think of the second binomial as my g function. Sometimes it helps to circle the factors. It just gives you a better visual. All right, you might be thinking, well, do I have to use the product rule for differentiation on this equation? No, I could FOIL and kind of clean it up and then do the power rule. At some point, we're going to have a choice on some of the equations and how we find the derivative. For this one, you did have a choice. You could do the algebra, the rewrite, using FOIL or boxing, whatever, and then do the power rule. Or, now that we're learning about the product rule, we could use that too. So it just becomes a personal preference. All right, well, this equation is ready for me to find the derivative using the product rule, so naturally I'm going to go to the h prime. All right, so what the formula said is that we're going to leave the first binomial alone, and we're going to multiply by the derivative of the second binomial. Well, we're going to go ahead and do the setup on this. Okay, well, the derivative of the second binomial would look something like this. That's an x. Okay, now we have more action to do. We'll do that in the next step. We're just doing the setup on it. Plus, now I'm over here in the product rule. Plus, it's the second factor left alone, the g left alone, times the derivative of the first. Instead of my just finding the derivative right away, I'm going to do the setup. I'm going to take an extra step. That's okay. Take an extra step so I really understand what's happening in this formula. All right, as I scan this right here, I see that I have more work to do. I have a derivative operator here, and I have a derivative operator here. Okay, at this point, I'm going to look in here and we'll go, well, the derivative of 5 goes to 0, and the derivative of 4x goes to 4. So I'm going to actually end up multiplying by 4. And in my next step, I'm going to pull the 4 up front here, or I might even possibly distribute through. It just depends on what I'm going to get out over here. All right, so I took care of that derivative. I'm at the plus sign. Write down 5 plus 4x. Okay, looking in here, I need to find this derivative. It's the power rule. So 3 minus 4x. Okay, and where we're at in this problem would require us to multiply the 4 in here, FOIL these two together, and then collect. So distributing the 4, I'm going to get 12x minus 8x squared plus, I'm going to come over here and box or FOIL, 5 times 3, outside, inside, 2 last terms multiplied, a little bit of cleanup and we'll be done. I don't know if you guys are experiencing that delay on your side with the voice and everything. I hope not. All right, let's put this in descending order for our variable x. So it looks like we've got negative 8x squared, negative 16x squared, negative 24x squared. The linear terms, I'm going to collect my 2 positive ones first. That would seem smart. That's 24x and then minus 20x. So that leaves plus 4x. And then our constant terms, it looks like I only have one, plus 15. It seems to be more algebra in that problem than there is calculus. Okay, let's look at a second example of using the product rule. I'm really bothered by this delay. Just don't have time for it. Okay, that's kind of messy because it's hard for me to see. But anyway, let's look at this. This is y equals 3x squared times sine x. 3x squared times sine x. Well, notice the variables, notice the product. Okay, what you might want to do, oh, I'm afraid to change colors. Okay, is you might want to identify what differentiation rule do I need to use here. Well, this is not the power rule by itself. There's no plus or minus in here. Okay, so we have a product and we have 2 factors that have a variable in it. So we'll call this the f function and the g function, or whatever you want to call them. Doesn't matter. All right, so I've established that I need to use the product rule for differentiation. Okay, and in this case, it's really behaving badly. Okay, y equals, okay, let's try this. I don't know. Y prime equals. Please, please work. Okay. All right, so it's f g prime plus g f prime. So it's f g prime plus g f prime. So f left alone. Oh my gosh. Times the derivative of g. You can do the setup. So show what you're going to be finding the derivative of. Plus the second factor, sine of x, times the derivative of the first factor, 3x squared. I know some of you guys are going to be comfortable without writing this step, and you can go right to this y prime final answer. But let's practice the setup for a little bit. All right, so this tells us we have some more work to do because I see those derivative operators. You just can't leave those hanging there. So the derivative of sine, we've come to know as cosine. So I would typically put it right behind the 3x squared. Plus, come over here, I still have to find the derivative of 3x squared, which goes to 6x. Well, where am I going to put 6x? We typically don't put it right here behind the x because it almost looks like you want to multiply x by 6x. So what we do is we'll move 6x up front. The only thing left that you could do is you could look for a common factor in both these terms, and I can see that in term 1 and in term 2, I have a common factor of 3x that could be pulled up front, divided out. Okay. Other than that, there's nothing else you can do. So I would say that we're pretty much finished. Let's see if we can look at another example. So here we have number 3. As you can see, we have y equals, we have a difference of 2 terms. So what we have to do is we have to look at each term individually and see what kind of differentiation rule we need to use. So in this first term right here, I see I have a product, 2x times cosine x. So for this first term, I'm going to have to use the product rule. But when I come over here and I look at this last term, you could use the product rule with 3 being f and sine x being g, but why when you can just use the constant multiplier rule? And this is just a constant being multiplied by a function in terms of x. So if you want to do the product rule, fine, it's just extra work. You'll get the same answer as if you would just use the constant multiplier rule. So I guess I'm ready for differentiation, so I'm going to go ahead and change to the prime. Okay, I'm afraid to switch colors on my pen because that sometimes messes things up. So that's F. This is G. Let's focus our attention on this term and using the product rule. So it's the first term left alone. Do the setup, derivative of the second term. Plus, I'm still involved in the product rule, the second, G, left alone, times the derivative of the first term. Now I'm going to go on to the second term, minus 3 sine x, and I'm just going to do the constant multiplier rule. 3 is kind of on hold as you tackle the derivative of sine, which is cosine. So I've differentiated the last term. It's just going to come down as I work down on the rest of the problem. So y prime equals, the derivative of cosine is negative sine. So the negative needs to be moved all the way up as a -1 multiplier and adjusted in front. So negative, keep the 2x. Remember that went to sine x, and that's what you're going to record here. Move on, plus the derivative of 2x is 2. You're going to put that up front, plus 2 cosine x. This, remember, came from the derivative of the second term, so just bring that down. And if you do one final scan to see if there's anything left you can do algebraic, I see I can collect like terms. So we've got y prime equals talking about these two like terms, they collect to -1 cosine x. As I scan this final derivative answer, I don't see a common factor that would otherwise be divided out and pulled up front, so I would say that I'm done. All right, so for example 4, let me see if I can get through this without too much pain. Okay. So notice that we have a function and it's made up of a product of a binomial and a trig function. All right, some options you have here are you could distribute cosine in doing some algebra and then tackle each term to see what kind of differentiation rule you need to apply. Or you could go straight to finding the derivative by using the product rule. Totally up to you. Personally, I probably would just go jump right into the product rule, paying attention to x plus 1 being f and cosine x being g. First factor x plus 1 left alone times the derivative of g plus the second factor left alone times the derivative of f. All right, so for this first big group, the derivative of cosine is negative sine. So put the negative up front in front of the quantity. Keep the sine part of it behind the quantity. It's just kind of common practice. Plus, okay, and we still have more work to do here. The derivative inside this linear function is just 1, and so we just have cosine x. All right, what else to do? You could distribute the sign inside, taking the opposite of both terms, but that's not going to allow you to clean up anything because there's not going to be any common terms or like terms. Okay, so I applied the product rule on this one, although I didn't have to from the beginning. I could have distributed the cosine in and then found the derivative of each term, which if you did that algebra and distributed cosine into x, you're going to have x cosine x, which means you're going to have to do the product rule anyway. So my choice was just to get started with the product rule. All right, so hopefully that wasn't too painful for you with the delay in the pen. Okay, hopefully you survived. I guess I'll know tomorrow when I see you.